Good morning, geometry. It looks to me like I did day 4 notes, or I posted day 4 notes yesterday. So today is day 4, but these are day 3 notes. Okay, so let's talk about degrees and radians. First of all, what is a degree? A degree is 1/360th of a circle. Okay, so whatever 1/360th is, that if 360 of these equally went around here, right? That would be 1 degree of this circle. Okay, so 360 of these within a circle. Obviously, 360 of the ones that I drew won't fit, but that is 1 degree. However many 360 of those can go around one entire circle. Right? Radians are a little bit different. Radians are talking about the radius. Okay, so how many radians can go around one circle? Well, the way it works is radians. If we talk about a circle, we have something times pi for the revolutions of a radian, right? So if we're talking about the center line here, 1 radian would be a half circle. That is 1 pi radians. 1 pi radians is 1/2 of a circle. And then the other half of the circle would be an additional 1 pi in radians. So a complete 360-degree circle would be worth 2 pi radians. Okay? So 1/2 of the circle is 1 pi. Then another half of the circle is another pi. So together, one complete circle is 2 pi in radians. All right? So if the first page in your notes on the PDF file shows you the comparison chart between degrees and radians. So check that out real quick. There's a great equation right there that's posted first that helps you find radians and helps you find degrees if you have radians. Make sure you check that out. And that is actually the definition in the second slide after that. So in the last page, I guess. The definition says use a proportion between degrees and radians. So number of degrees to convert back and forth between degrees and radians, we have numbers of degrees over the total number of degrees in a circle, which is 360. And we set that equal to the number of radians, or whatever pi, right? So number of radians, it'll be something pi, okay? Or even a fraction with pi, over exactly how many radians are in 360 degrees, which is 2 pi. So we know a complete circle is 360 degrees and a complete circle is 2 pi radians. So whenever we're looking for either radian or degrees or radians, we just put the one we do know up here, cross multiply, simplify, and you'll find your answer for the other one. So the first example that it shows you on the comparison chart is actually the first one that we do. So number one, it says that we're changing 60 degrees to radians in terms of pi. When it means in terms of pi, it means you better have pi in your answer. Anytime it says in terms of x or in terms of blah, it means to have that value that it just said in your answer. So we need to have the symbol for pi in our answer. So it says 60 degrees. We're starting with 60 degrees. We know there's a total of 360 degrees in a circle. We're going to set that equal to x for our unknown number of radians, but we do know that there are 2 pi radians in a complete circle. So we're going to cross multiply here. 60 times 2 is going to give us 120 pi. And then 360 times x, we're going to set that equal to 360x. Now, I want x all by itself. I'm missing this number right here. So I'm going to get everything away from that by dividing by 360 on both sides. And then I'm going to simplify these two numbers right here. 120 divided by 360 is 1/3, or I'm just going to have pi over 3. So 60 degrees is equal to pi over 3. Does that make sense? I certainly hope so. All right. So let's do number 2. Number 2 says 90. Let's do the math. 360 is equal to something over 2 pi. All right. So you could do this from memory because we talked about this at the beginning, or you could do this with me. So let's multiply, cross multiply. 90 times 2 pi gives us 180 pi is equal to 360x divided by 360 on both sides. And we get, that becomes 1/2. So we get pi over 2 is equal to x. So this was 1 radian, or pi. 90 degrees would be half of that, or pi over 2. So that is our final answer. 120 degrees for number 3 would be 120 over 360. It's going to be the same comparison over and over and over again. X over 2 pi. We're going to cross multiply and get 240 pi is equal to 360x divided by 360 on both sides. And I end up with, this becomes 2/3. So 2 pi over 3 is equal to x. Number 4 is 270. So 270 over 360 is equal to x over 2 pi. Cross multiply. 270 times 2 is what? 54? 54. So 540. Double checking myself here. I'm probably right. 270 times 2, 540 pi, and that's equal to 360x divided by 360, and I end up with 3 over 2, so 3 pi over 2 for our x. Okay, let's look at the next set. It's number 3 again. We're going to use the same thing to find radians, or to do it, mark it up with radians. So the new number 3 says we're starting off with pi over 3. Pi over 3. So pi over 3 is the number of radians over 2 pi for however many radians are in a circle. And we're looking for how many degrees would that be. And we know that there's 360 degrees in the circle. So we're going to multiply, and we're going to get 2 pi x and 360 pi over 3. So 360 pi over 3, and that's going to be equal to 2 pi x. Now, this reduces to 120. So 120 pi is equal to 2 pi x. I'm going to divide both sides by 2 pi. And I'm going to get, that cancels out. That cancels out. 120 divided by 2 is going to give me 60. So I know 60 degrees. X is 60 degrees. All right. The new number 4. Number 4 says 3 pi over 4. I'm going to set that over 2 pi. I'm going to set that equal to x over 360. I'm going to cross multiply, and I'm going to get 2 pi x on this side. 1 second. 360 times 3 pi. 360 times 3 is going to give me 1,080. So 1,080 pi over 4, because that's what 360 times that is. So 180 divided by 4, or 1,080 divided by 4, is going to give me 270. So this will be 270 pi divided by 2 pi x. Divide both sides by 2 pi. That cancels out. 270 divided by 2 is going to be 135. So 135 degrees for that value. All right, we have a new equation down here at the bottom. It says the length of an arc over the circumference is equal to the degree measure of an arc over the degree measure of a circle. So it's saying that this arc measure, like how long is it, how many inches is it, in length, we call that S. Okay? This length is S. This degree measure is the same as the minor arc inside of it. These are going to be the same number of degrees. So we're going to have S over the circumference. How do we find circumference? Either pi times d, which is the diameter, or 2 pi r. Either one. But this example, we're given the radius. And we're going to set that equal to the degree measure of the arc over the degree measure of a circle. So whatever the arc is, over 360. Okay? So let's set this up. And also, if you read down there, it says, if the angle is in radian, then S is equal to r theta, where S is the length, the arc length, r is radius, and theta is the angle in radian. So there's two different ways we can find this. If we're looking for arc length, we use S. If we're looking for the number of radians, or we're looking for the radius, we can do the same equation with r times theta over 2 pi r equals the arc length over 360. Now, once again, this can reduce right here, which takes you all the way back to what we just got through doing. So theta, or the number of radians, over 2 pi, or the number of radians in a circle, is equal to the degree measure over 360. It's the same thing we just got through doing. Okay? So this is arc length, and this would be for radians. Let's find both. All right, so it says that our radius of z is 13.5. Our radius equals 13.5. And then it says find arc QR if the measure of QZR is 60 degrees. We know that that portion is 60 degrees, the arc measure QR. Okay, let's plug this in and figure it out. So we're going to be using this equation up top here. I'm looking for my arc length. So S over 2 times pi times 13.5 is equal to the arc measure, 60 degrees, over 360. I'm going to cross multiply and get 360S is equal to 120 pi times 13.5. Let's go ahead and simplify this to say, what is that? 120 times 13.5. That's going to give me 1,620. So 360S is equal to 1,620 pi. Okay? Now, I need to get S all by itself. I want to find that arc length all by itself, or that arc measure all by itself. So divide both sides by 360. And I'll get S is equal to 4.5, or 9 over 2, 9 pi over 2. Well, that doesn't tell me how many inches. This is exact, right? That would be the exact number of inches. But I need to round to the nearest hundredths place. I just want to find out how long, right? How long is this item? So I'm going to go ahead and type that into my calculator. 9 pi divided by 2. And I'm going to get 14. S is equal to 14.1, almost 4 inches. Okay, so this would be the exact measure, but this would be the estimated measure. Estimated. All right. That concludes this video. The other way is just what we've been doing. Y'all have a great day, and I will talk to y'all later.